Welcome back to another lesson. In this lesson, we will learn about the turning point form of the quadratic equation. The turning point form of the parabola can be represented as y equal to a of x minus p squared plus q, or you can have y equal to a of x plus p squared plus q. The way you represent it between these two forms really doesn't matter, but what matters is that you should take note of the sign. In this case, you have x minus p. That means the value of x is going to be positive, so it's going to be the opposite sign. And if x is plus p, the value of x is negative p. So you should take note of how your equation is given. Remember, I have not told you what is p, what is q, but we're going to get to what is p, what is q, what is a. Let's go back to our standard form of the quadratic equation, which is y equal to ax squared plus bx plus c. So from this equation, I'm going to show you how do we get to this form and what is p, what is q from what we know from the standard equation. So from this point, we're going to complete the square. I'm going to run quick here because this is not about completing the square, but I can make another video as to how to complete the square. So let's complete the square. We have y equal to a. We're going to take a common factor of a, and we have a squared. And in this case, we're going to have b over ax plus c. We didn't take any common factor from c. So let's complete the square. When completing the square, remember, you have x plus a squared is equal to. So we're going to take this form and put it here. So we do not know what a is in this case, so we're going to have to add a. So we have to take the coefficient, we have the coefficient of x and square it to get ax squared, right? So we're going to take the coefficient of x and square it. So we're going to take the coefficient, which is b over a, and square it. We take half of it and square so that we can get a squared. So we take this and put it there. We're going to have y equal to a of x squared plus bx, ba. So in this case, I want you to note that we added a new term here. And this is the equal sign. This is no longer equal to the original equation we had. So whatever we added, we're going to have to subtract. But now, we didn't just add b over 2a squared. This is multiplied by a. So we're going to have to subtract this multiplied by a. So we have that. And then now we can take this to a perfect square. And we have y equal to. And we have that as our equation. And this is your turning point equation. So we go back. So you can see that this equation is similar to that equation. And from that equation, you can pick up that, oh, the value of p is b over 2a. So that means x is equal to minus b over 2a in this case. So this, from the standard equation, what did it mean? And we know that this represented our x value of the turning point, and it also representing the axis of symmetry because the parabola is symmetrical by the x value of the turning point. So this is our turning point, meaning p from the equation is the x value of the turning point. And then we go to q. You see q here, it is not your y-intercept, y. Remember c from the standard equation is your y-intercept. But now c, you have other constants that are adding to c. So q is not your y-intercept. But q, if you substitute x of minus b over 2a here, you're going to get 0. And then you're going to get this value. Meaning when you substitute the x value of the turning point, you get this part here. You get that part. Meaning this part is your q value. That is your q value, which is your y-intercept of your turning point. We know now that q is your y value of the turning point. So p and q represent your turning point. and hence this equation is called the turning point form. So let's do an example to see what are the effects of P and Q. The basic equation that we had from the standard form was y equal to x squared. So we're going to build from here, and we're going to have y is equal to x plus 2 squared minus 4. And here we're going to dot down what we have. We have P and Q. And the value of P is minus 2 and the value of Q is minus 4. Why minus 2? But we have 2 here. Remember I said you're going to have to equate this to 0 and x is equal to minus 2. So the value of P is the opposite sign of what is written here. So P is going to be negative 2. So how do we draw this? We have the turning point as minus 2 and minus 4. So from here, I just want to show you what is the impact of P and Q. So we're going to draw this point. This is minus 2 and minus 4. So it's going to be somewhere there. So we have a turning point here. And the value of A is positive 1. That means our parabola is concave up. So I'm just going to draw something. So I do not know the value of these turning points, but I want to show you something. From the original graph, we had the axis of symmetry, as x equal to 0. And now we have new axis of symmetry, which is x equal to minus 2. What is it that you can see here? What can you conclude from this point? You can see that we have x from 0 to minus 2. That means our graph shifted to the left by 2 units. So you can already see the influence of P, that the P value shifts your graph from the left or to the right. If it's negative, in this case, it's going to shift to the left. And if it's positive, it's going to shift to the right. So P is responsible for horizontal translation. Even it is a turning point. It is a value of a turning point, but it is also responsible for shifting your graph horizontally horizontally from the left or to the right. So we know what P is. And then the Q value. You can see that the turning point was 0 there, but now the turning point is here. That means it shifted downwards. You can see now that the influence of Q is that it is responsible for vertical shifting. It shifted from 0 to Q. 0 to 4 in this case, to minus 4. And if ever our example was x minus 2 plus 4, you can see that the turning point in this case was going to be 2. We're going to draw this point here. So this is 2 and 4. So you can see that the turning point from here shifted 2 units to the right and shifted 4 units upwards. So you can really see that P is responsible for horizontal shifting and Q is responsible for vertical shifting. So that is your influence of P and Q. I want us to complete the example y is equal to x plus 2 squared minus 4. So we can have a full explanation of how we can use the turning point equation and how can we draw a graph from the turning point equation. So we have 2 points that we know already, which is the turning point P and Q, and we said it's equal to minus 2 and minus 4. So we can go to our graph and draw this point already. So we have minus 2 and minus 4. So we have that point here. And then we can do a table, or you can do the transformation way of having to move every time from the standard equation that we know, that is x squared. So you can choose to use x squared, and then from every x squared value you have, you can shift 2 units to the left, and then you can shift the y value 4 units downwards. So you can choose to do that, but we're going to use the table. So we're going to substitute the x values and get y. So when x is minus 4, we have minus 4 plus 2 squared minus 4. And here we can see that, okay, we have minus 2 squared minus 4. and that gives us 0. So the x value is 0. And you do the same for -3, -2 until 4. So we're going to take these values and we plot them there. We can start with -4. So that is the graph when you're using the table form. Now, what can you deduct from the graph? What is the graph telling you? So you saw that, okay, I had a is equal to 1 and my graph is concave up. So that part is correct. And my q value is -2 and -4. That means my turning point is -2, -4. That is correct. What else can we tell from this graph? So you need to calculate, or you need to write your range. Remember your range from the introduction, we say it's where your graph is defined on the y-axis. So you look at your y and see where is your graph defined. You can see that it starts from the turning point. So your y should be greater or equal to -4. That means your y should be greater or equal to your y value of your turning point. If ever this was concave down, it was going to be the other way. Your y was going to be less or equal to your turning point. But this is not the case here. We have a concave up, so our range y should be greater or equal to q. And our domain is where the graph is defined on the y-axis. So you can see that the graph is defined for all the x values. So x is the element of real numbers. So let's summarize here. You can find your turning point. That part is fine. You know how to find your domain and the range. That part is fine. You also know how to find your x and your y-intercept. Those are your y. This is your x-intercept and this is also your y-intercept. You can make x to be equal to 0 to find y-intercept, and you can make y equal to 0 to find the x-intercept. And another thing that we deducted here is that P and Q, the value of P is also the equation of the axis of symmetry, because we can see now that the graph is symmetrical by x is equal to the P value. So if they say in this equation, in this question, write the equation of the axis of symmetry, you can say that, oh, x is equal to -2. So we've covered everything from this: the turning point, the domain, the range, the effect of A, and how to find your axis of symmetry. Thank you for watching. Please do comment down below on what you would want to see on other videos. I would really appreciate that, and I will see you on the next video.